What is the probability that a randomly selected variable would fall within 3 standard deviations of the mean? Well, that refers to our 68, 95, 99.7 rule. Yeah? You remember that? Here is your mean, or your mu, or your x bar, or whatever. And then you have 1, 2, 3 standard deviations above. 1, 2, 3 standard deviations below. And this range covers 68% of the data. This range covers what percent? 95%. And this part is 99.7%. So 3 standard deviations above or below is 99.7% of the data. Percentages you may want to put on your note card. Okay? All right, for the data set here, find the 5-number summary, the range, the IQR, the mean, standard deviation. Okay, I'm going to need some separate paper for this. Here we go, 76. I'm going to write these down in order from least to greatest. What's the smallest one? 1.1? What comes after 1.1? 2.7? Then what? 3.1? And then 3.4, and then 5.2 and 7.1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Find the 5-number summary. That would be what? That would be your Q1. I'm sorry, that would be your minimum. Q1, Q2, also known as your median. Q3, and then your maximum, yes? Well, I know the minimum is, sorry, mechanical pencils and me are not friends right now. Minimum is 1.1. What's my max? 7.1. Q2 is going to be exactly in the middle, which would be right in the middle here. What's halfway between 3.1 and 3.4? How do I find out? 3.1 plus 3.4 divided by 2, 3.25. So far, so good. How do I find Q1?
Plus the quadrant to minimum.
Over here. Nope. Over here, what's my median? 3 numbers. That's the median of them. That's Q1. Over here, 3 numbers. That's the median. So there's my 5-number summary. So this was part A, correct? Part B says find the range. Well, that would be the maximum minus the minimum. 7.1 minus 1.1 is 6, so that's my range. Find the IQR. For part C, how do I find the IQR? Q3 minus Q1. So 5.2 minus 2.7. 2.5. So far, so good. Part D, find the mean. How do I find the mean? 1.1 plus 2.7 plus 3.1 plus 3.4 plus 5.2 plus 7.1, all divided by what? 6? And I call that 3.77 because it's 3.76666666. All right, and the population standard deviation. Population standard deviation. I think we need to find it of the sample and the population, but we'll see. Okay, so how do I find the standard deviation? Take the number, subtract the mean, right? Next number, minus the mean. Next number, minus the mean. Uh, 7.1 minus 3.77. Okay, what do I do once I get those answers? Square them. Okay, so 1.1 minus 3.77 squared. Did I do that right? 1.1 minus 3.7 squared is... Why am I getting two different answers? Somebody check me. Okay, that's correct. Squared. 7.1289. Okay, 2.7 minus 3.77 squared. 1.1449. 3.1 minus 3.77 squared. 0.4489. 3.4 minus 3.77 squared. 0.1369. 5.2 minus 3.77 squared. 2.0449. 7.1 minus 3.77 squared is 11.0889. What do I do with all these guys now? Add them all up. So that one plus 2.0449 plus 0.1369 plus 0.4489 plus 1.1449 plus 7.1289. And I get 21. There we go, breaking my pencil again. 21.9934. Now I'm going to take the square root of it, but what do I have to divide it by? 6 minus 1. That's for our sample standard deviation. Okay, so I'm going to divide it by 5, which is 6 minus 1, right? And then I'm going to square root the answer, and I get 2.097. I'm going to call that 2.10, if you're okay with that. Okay, now my standard deviation is slightly different than the one on the key, probably because I rounded off here, didn't I? So every time I round it off and then I squared it, it gets me a little bit further from the actual one. But you should be, because this is a multiple choice test, you should be able to get close enough to the actual that you should be good to go. Okay? Let's see. How is it different if we wanted the this was the sample. What if we wanted the population? You would take it and you would take your 21.9934 and you would divide it by 6 instead of 6 minus 1. And that gets me a standard deviation of 1.91, which actually is what the key says. So if you're looking for the sample, you subtract 1. Population, you don't subtract 1. Okay. All right, that's all for number 76. Let's look at number 77. Classify each of the following as categorical or numerical. Do you remember what categorical means? Categorical, the mean has no meaning. Numerical, the mean does have meaning. So height, would you consider that categorical or numerical? Numerical. Years it takes to complete college. Numerical. Favorite number? Categorical. Why? Because does the average favorite number have any significance? No. Eye color. The numbers assigned to interstate highways. Categorical. Why? Because if I took the 5 plus the 215 plus the 10 plus the 210 plus the 91 plus the 60 and I average them together, that mean has absolutely no meaning. Right? Shoe brand. And shoe size? Numerical. All right, a survey asked a random sample of 50 EHS students if they plan to study more than 5 hours for their final exams. Who's the population? The population is all EHS students. What's the sample? 50 EHS students. This is the one where you have to remember statistic goes with sample, P goes with parameter. So they give me, do they give me anything? The statistic would be the number of students from the 50 to study. What, more than 5 hours? The parameter would be the number of students what? From where? From all EHS. So the statistic would be a result of your sample group. The parameter would be the result of the population group. So? Yeah? Okay. I have no idea why there's no 79. So 79 we'll skip over since it doesn't exist. 80. Tell which sampling method is used for each scenario. Systematic, stratified, convenience, simple, random, self-selected, and cluster. Those are my options. So letter A. The residents in a retirement community are split into groups based on their age, and then 10 people from each group are asked which classes or activities they prefer to have offered in the community center. So they're separating it into groups, and then what are they doing? They're taking some from each group. That is stratified. Part B. Residents of the retirement community are randomly chosen from a list of all residents, and then their ages are recorded to find a mean age of all community residents. Randomly chosen from a list. Simple, random, sample. Residents of a retirement community are divided based on which apartment building they live in. And then 5 of the 20 buildings are randomly chosen to participate in the survey. So they're still broken up into groups, but then they're taking entire groups. What's that? Cluster. A pollster stands outside the community center at the retirement community and asks every resident who enters about their favorite activities. Convenience. It would be systematic if the person asked like every third person or every other person. But when they ask everyone that's coming in, they're just getting as much data as they can, as quick as they can. That's convenience. Okay? Ready for 81? All right. Make a line or a dot plot of the following data and decide if it is symmetric, skewed left, or skewed right. All right, so let me get a line plot set up here. So I'm going to do it actually right here. I need, let's see, what's the smallest number on here? Is there a 1? Nope, it looks like it goes 2, 3, 4, 5, 6. I do see a 9 in there. So I'm going to have to go something like that. Yeah? All right. 2, 8, 4, 6, 4, 4, 3, 3, 9, 6, 4, 5, 3, 2, 5, 6, 4, 4, 4, 5, 5, 6, 3, 3, 4, 4, 5. Okay. What do we have here? The big part is here, and the tail is over there. What does that mean? What was it?
Skewed right.
Skewed right. The skew direction is based on where the tail is. So we have it skewed right. That's number 81. Okay. All right. 82. All right, we have a histogram here. Let's see. What we can see is we have 2 people in this column. We have 0 in this column. 4, 1, 9 in this column. 1, 1, 2, 2. I know it's kind of hard to read, but we'll do the best we can. Is it true or false that less than 8 people are shorter than 67 inches? Where's 67 inches? Here is 67.5, I think. Yeah? We have 59.5, 61.5, 63.5. It looks like they're counting by 2.5s. So, less than 8 people. Well, we have 4, 5, 6. This person, we don't know. They could be 67.1. We don't know where they fit in that category. But we do know that even if that person is included, is that less than 8 people? Yes. So part A is true. Part B, there are an equal number of people who are 74 and 76 inches tall. Here's 74, here's 76. Do we know that? Do we know that that's an equal number of people who are 74 and 76? Do I know how many people are 74 inches? No, I only know how many people are between 73 and a half and 75 and a half. I don't know if they're exactly 74 inches tall, right? So I'm going to say false simply because I don't have enough information. This graph isn't specific enough. There are more people between 67.5, which is right here, and 69.5 than any other height. That's my tallest bar. That would be a true statement. Okay. There were 22 people in this sample. Well, let's add them all up. 2, 4, 5, 6, and 9 would be 15, 16, 22. True. The tallest people in the group were between 67.5 and 69.5 inches tall. So were the tallest people in the group in the tallest bar?
No.
Where's the tallest people?
57.
They would be all the way over to the right, wouldn't they? So that would be false. F, the shortest person in the sample was 59.5 inches tall. 59.5 is my starting measurement. Is that a true or a false statement? It is false. The shortest person in this study is somewhere between 59.5 and 61.5. I don't know that they're 59.5 inches. I just know what range they're in, so I can't conclude that they were indeed 59.5. The tallest person in this sample was more than 75 inches tall. Well, let's see. The tallest person would have been between 75.5 and 77.5. So if they have to be at least 75 and a half inches tall, then we can say yes, the tallest person is bigger than, or is taller than 75. Any questions about the histogram? All right, on to the last one. The mean age of all students at EHS is 16 years old with a standard deviation of 0.7. I think this is asking me to do a bell curve. Yeah? My mean goes in the middle. What's the mean? 16.2. And I have 1, 2, 3 this way, and 1, 2, 3 this way. And how do I find the markings for those spots? Add and subtract the standard deviation, right? Standard deviation is 0.7. That makes this one 16.9 plus another 0.7 is 17.6 plus another 0.7 is 18.3. How do I find the other side?
Minus it.
Yep, subtract 0.7. I get 15.5. Another minus 0.7. 14.8. And another one, 14.1. Remember, these are the ones that take a few minutes to set it up, but then once you set it up, the answering of the questions goes pretty quick. Okay. Do we remember the percentages that go in these categories? 34 and 34. Remember, that makes up your 68%. And then we have what? 13.5%. By the way, might want to put those percentages on your note card. Then we have 2.35%. And finally, 0.15%. All right. Yes.
This is the one where it's always the same.
Yes.
Decimals.
Yes.
Percent.
Yep. What interval captures 99.7%? Now, this is kind of like that first stats one that I did. It would be from 3 below to 3 above. So 3 below would be 14.1 to what? 18.3 years old. What is the probability that a student is older than 17.6? Well, if this is my boundary for 17.6, older would be to the right of there. So 2.35 plus 0.15 gives me 2.5% is my probability. So? What is the probability that a student is younger than 17.6 years old? So in other words, add all these guys up. Yeah?
Yeah.
Or if I know that only 2.5% are older, couldn't I take 100% and subtract 2.5% to get the same answer?
Yeah.
And what does that give me?
97.5.
Just a little quicker way to get to that answer. What is the probability that a student is younger than 15 and a half? Here's 15 and a half. Younger would be 0.5 plus 0.15 plus 2.35 plus 13.5. 0.15 plus 2.35 plus 13.5. 16%. Okay. The last two, I need to get a chart out. Hang on. So how do I know I'm going to need a z-score table for these two? Because if I look at 18 years old right there, that's not one of my numbers, is it? It's somewhere in here. Yeah?
Yeah.
So I have to do the z-score table. So for part E, I'm going to do 18 minus the mean. What's the mean? Divided by the standard deviation. Another formula you might want on your note card. The number minus the mean divided by the standard deviation. What do I get? 18 minus 16.2 is 1.8 divided by 0.7. And I get a fairly long decimal, but based on this chart, I really only need 2 digits past the decimal. So I'm going to call this 2.57. Now, when I go to my z-score table and I look up 2.57, will that give me the probability older than 18 or the probability younger? It's going to get me the probability younger. So what am I going to have to do? Take 100% and subtract what I find. So when I look for 2.57, here is 2.5, 2.50, 1, 2, 3, 4, 5, 6, 7, 99.49%. So 99.49% of students are younger than 18 years old. Does that seem reasonable for a high school? That a huge majority would be younger than 18 years old, right? How do I find the older than? 100% minus 99.49%. What does that give me? 0.51% are 18 or older. So? Okay. And finally, we have a between question. Is 15 on my bell curve? No. Is 17 on my bell curve? No. So here's what I have to do. I have to find the z-score for 15, get the number off the chart. The z-score for 17, get the number off the chart. And then take those two chart numbers and subtract them. Okay? So I'm going to start with 15. So this is part F. So 15 minus 16.2 divided by 0.7. 15 minus 16.2 divided by 0.7, negative 1.71. And on the z-score table, that translates to what? Negative 1.71 is right here. That's 4.36%. So far, so good. Now I'm going to find the z-score for 17. So 17 minus 16.2 divided by 0.7. 1.14. Which on my chart translates to 1.101234, so 87.29%. So what do I do to find between? I take the bigger percent and I subtract the smaller percent. Goodness. All right, so 87.29% minus 4.36%. And what's my answer? 82.93%. I'm glad it's my last one because I'm running out of paper there. All right, there's the stats part. Happy studying.